Hey, welcome back to your favorite pre-calc class. Let's get into evaluating radicals, and let's talk about the roots of a radical. So I'm going to give you the formal definition of the square root. You know, if the square root of a equals b, if and only if a equals b squared. Technically, that's what that means. So, like, let's think about for a minute, like the square root of 49, right? The second root of 49, square root of 49. Well, we know that that is 7, right? Because 49 is 7 squared. But think to yourself for a minute, is there another number squared that gives me 49? Is there another number squared that gives me 49? Yeah, negative 7. Isn't negative 7 squared also 49? So technically, by the definition, the square root of 49 is actually 7 and negative 7. But when most textbooks or homework problems and stuff, when they're asking you to find the square root of 49, they're usually just asking for the principal root, the positive one. They just want the principal root on those. Okay, so like this one down here, the first example, the square root of 49, square root of 100. If we're finding the square root of 100, the second root, we know 10 times 10 is 100. We're just going to say it's 10. We're not going to give both roots on that. We're just going to give the principal root. Let's do some more here. I got negative the square root of 36. Let's see. Square root of 36, we got 6 times 6, right? So we got the negative in front. We found the principal root of the square root of 36, which is just 6. So negative in front stays there. Square root of 36 is 6. So we end up with negative 6. Try that next one. Next one, we've got the square root, and go ahead and check your try problem there. But we've got the square root of negative 144. So we're saying, well, is there something times something gives us negative 144? And hopefully you say, no, that's not going to work. Remember, if the square root of a equals b, if and only if a equals b squared, right? So if we have the square root of negative 144, there's no two things being multiplied to give us negative 144, because if we multiply two things together, we're going to have a positive, right? So this is not going to work. I cannot have an even root, right? This is a second root, it's square root. Can't have an even root of a negative number underneath that radical. This is not a real solution. So in the real numbers, this is no solution. And right now we're just working in the real numbers. Now from last section, we know we can take an odd root of a negative number. That'll work, right? In the real numbers, but not an even root. Well, let's look at this next one here. I would go ahead and simplify that. 9 plus 16, and I would get 25. And I am taking a second root, right? So I'm looking for 2 of a kind. Square root of 25, of course, is 5. The square root, now that is different than the square root of 9 plus the square root of 16. These are not, I would have to simplify these, all right, before I could add these, right? They're not like terms. So square root of 9 is 3, square root of 16 is 4, and then we can go ahead and add those integers. Next you try a problem, if you want to pause that video, you get 3 minus the square root of 25, so we just get negative 2 on that. Next one, we've got 9 minus 25 is negative 16. I cannot have a square root or an even root of a negative number. No. So no real, that means the real numbers, no real solution. No real solution. How about square root of a fraction? We could break that up. We have the square root of 1 over the square root of 121. And the square root of 1 is 1. Square root of 121, that's 11 times 11. So square root of 121 is 11. So we just end up with 1/11 on that. Go ahead and try that next one. Let's do 1/14 on that. You try a problem there. We've got a square root of, again, we cannot have the square root of a negative number, so no real solution here. We're only working in the real numbers right now. Now, what if it doesn't go into it? Well, 2 times 72, you could go ahead and multiply, if you want to do it this way, 144. And by the way, this is not the only way to do these. So we end up with 12, right? Another way you could do it, let's say you just kept breaking it down. Like 72 is 2 times 36. And you know 36 is 6 times 6. So you have the square root of 4, which is 2, so 2 comes out. And you got the square root of 36, which is just 6. So then you just multiply 2 and the 6, and it gives you 12. So either way you do that, you're still going to end up with 12 if you do that properly, right? You get that 7 times 28. So if you could either multiply it and get square root of 196, which is 14. Got lucky, it worked out nicely for you. If you didn't know that, maybe the other way you could do that is you could just keep factoring it. You know 28 is 7 times 4. Remember, you're looking for 2 of a kind. You know 7 is 2 and 2. So you got the square root of 49, which is 7. You get the square root of 4, which is 2. And you just multiply those, you end up with 14 on that. Well, if you punch into your calculator, let's go ahead and pull up Decimal Scientific, punch in the square root of 26. But you notice there's it's not a clean root. Here's our Decimal Scientific. You could either punch in SQRT or you could just use that square root symbol right there, since it's just a square root. This is for anything else besides a square root, like a third root and so on. But we're taking the square root of, I think it was 26. So 5.099019,514. Round that to 3 decimal places, so to the thousandth position. So again, we look to the right, it's a 0. Since it's a 0, it just leaves it the same. All right, we don't bump that number up. 5.099. We could punch in the square root of 76 as well. So the negative stays there. I punch in the square root of 76 and I get 8.717797887. Again, we're rounding to the 3rd position. So I look to the right of the 7. I have a 7. It's 5 or more, so I'll bump it up. And finally, negative root 55. Square root of 55 would be between square root of 49, which is 7, and square root of 64, which is 8, right? So this will be 7 point something. So I punch that in, I get 7.416198487. Round it to the 3rd position. I'm looking at that 6 there, but to the right is a 1, so it'll just do the same. Negative 7.416. Well, let's get into higher roots. So the nth root of a equals b if and only if a equals b to the n. All right, so we've done some like this. So for example, the 5th root of negative 32 there's 5 of those. Negative 2 times 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 negative 2. Did I say that 5 times? Looking for 5 of a kind. So the 5th root of negative 32, the 5th root of negative 32, is negative 2 because negative 2 to the 5th is negative 32, right? that's what that means. So third root of 125. Looking for 5 of a kind. Third root of 125 is 5. So third root of 125 is 5 because 5 to the third is 125. Right? Third root of negative 512. Well, negative 512 is negative 8 times negative 8 times negative 8. So you get negative 8. Right? So third root of negative 512 is negative 8 because negative 8 to the third is negative 512. Right? Now this one's got that negative in front, so we're gonna have that negative in front, and then we're gonna take a look at the third root of 1331. So 1331 actually goes into 11. That's 11 times 121. And 121 is 11 times 11. So see how we have 3 of a kind, right? So the negative stays there. I get the third root of 1331, which is just 11. Our answer ends up being negative 11. Let's do a you try it problem there. $7.29 is 9 times 81, by the way. Don't forget you have that negative out front. So that'll end up being negative 9. All right, let's do a higher power. How about a fourth root of 1296? The fourth root of 1296. Well, 1296 does go into 6. It's 6 and 216. And then 216 is 6 times 6 times 6. So see how we have 4 of a kind. So this just ends up being 6. Fourth root of negative 1296. Well, does negative 6 times negative 6 times negative 6 times negative 6 give you negative 1296? No, it doesn't. That's positive 1296. This is not possible. Remember, we cannot have an even root of an odd number. We can't do that in the real numbers. This is not a real solution, right? Can't have an even root of a negative under that radical there. About a sixth root of 15625. I'm looking at the 15625 and I'm thinking, well, if it ends in a 5 or a 0, it's going to go into 5. So that is 5 times 3125. And that'll go into 5, right? 3125 divided by 5 is, so I have a 5 already. 3125 is 5 times 625. And 625 will go into 5. That's 5 times 125. So I got 5 and 5. The 625 is 5 times 125. And we know 125 is 5 times 5 times 5. So there's my 3 5s. 125 is 5, 5, 5. So I actually do have 6 of a kind, don't I? So this just ends up being 5. Right? Go ahead and try those last two. Hopefully you recognize that negative 3125 is negative 5 to the 5th, right? So I do have 5 of a kind. So the 5th root of negative 3125 ends up being negative 5. The 4th root of negative 4096, you can't take an even root of a negative number. You can't do that. Not a real solution. Now, 8 to the 4th is 4096, and negative 8 to the 4th is a positive 4096. But there's no way I can get a negative 4096 because I'm going to 4th power, right? So again, that's why that doesn't work there. Thanks so much for taking notes. See you next time.